Hello and welcome to the channel. I'm Will and I'm at it again buying rare and expensive video cards, which I probably shouldn't be. These two look cheap and innocent enough with just ordinary VGA connectors on them. You might be forgiven for thinking this is an ordinary 32-bit PCI VGA card and an ordinary 16-bit ISA one. But don't let appearances fool you. Although these have a VGA core, they have additional functionality on top, which is really quite interesting. And I'm not just talking about higher resolutions or color depths here. They can really do things that VGA can't. You see, both of these cards are based on another IBM video standard from the same time as VGA in 1987, called the IBM 8514/A standard. Only IBM could come up with a name that was so memorable. Now, if you wanted to buy an original IBM 8514 card today, well, you probably could, but first you'd have to find one. They were so expensive back in the day that they're as rare as hen's teeth now, and if you're anything like me, you don't even want to know what the price is. But fortunately for us, there were a couple of hardware clones produced. Now, I'm only aware of two that were 100% hardware compatible, the IIT AGX chip, which this card is based on, and the Ati Mark 32 chip, which this is based on. Not to be confused with the common as dirt Mark 64 chip, which you find in a lot of AGP video cards that came a little bit later. Now, both of these cards are relatively rare and expensive. I've seen clone cards online for anywhere up to €250 and probably quite reasonably priced given their rarity. Fortunately for me, these were a lot less than that. There's also the Ati Mark 8 chip, which is not 100% 8514 compatible, but pretty close. And I have an ISA card based on that on its way, and we'll take a look at that on a later video on the channel. But in today's video, I want to put these through their paces, and I want to show you what these can do that VGA can't, hopefully in a unique way that you won't be able to find anywhere else on YouTube. Also in this video, we're going to look at this interesting Paradise video card from the mid-1980s that I was tipped off about by a viewer of the channel. And I'm also going to set the record straight about an invention that I credited to the English in a previous video, but is actually French. But why was the IBM 8514 card so special anyway? This is a public domain image, by the way, not my card. And one of the reasons for that is IBM didn't manufacture a PCI or an ISA version of this. It was only available for their PS2 line of computers with their proprietary microchannel architecture slots. And the other reason I don't have one is they were very expensive on launch, around $1,300. And that was just for the base 16 color model with 512K of RAM. If you wanted 256 colors, you had to pay an additional few $100s to upgrade it to 1 megabyte of memory. And the card only offered you two resolutions, 640 by 480 and 1024 by 768. And not only that, but it wouldn't run on its own. You had to run it alongside an ordinary VGA card with some kind of pass-through, albeit a digital one, not an analog one like we saw on the 3D Effects Voodoo cards on the channel recently. But this card was some kind of graphics accelerator, a very early one for the PC. Basically, it was a blitter, something you'd associate more with an Amiga 500 than with a PC. Let's take a look at these graphics cards, and we'll start with the Ati Mark 32 one. The Mark 32 chip came out in 1992, and the boards were $199 at launch. I guess you could say they've held their value pretty well, actually. This board is a little later than that. You can see on the BIOS it says 1994. And it's a very interesting card because it says it's a graphics wonder PCI. And if you look in the internal ATI documentation for Mark 32 boards, there's no graphics wonder PCI actually listed. There's only a VISA and ISA version. The other thing that's interesting about this, if you look up the part number on this board, you'll get a bunch of Mark 64 cards online. And basically what ATI did is made a single PCB that could be set up in multiple different ways. You can see that there are three different sizes of RAM DAC that can be put onto this board. And actually under the sockets here, there are solder pads for chips. And you could have additional memory soldered onto the board. The ones that are on here are just DRAM, and basically they're 256K by 4 bits each, which means with 8 of them you get 1 megabyte. And this board can obviously be expanded out to 2 megabytes. As I said, some of these boards actually have a Mark 64 chip on them, and that's because the Mark 64 came out in 1994. So this is a very late Mark 32 card. So apparently the chip and the RAM run at 10 megahertz on this, and it's 80 megabytes per second because there's a 64-bit data bus between the chip and the memory. Of course, the card itself is just a 32-bit PCI card. The Mark 32 chip is great, and not just because it contains an 8514A coprocessor and a VGA core, but because it's documented. There's this programmer's guide to programming it at a register level. Importantly for us, there's a section on the 8514A coprocessor registers. So this is how we actually get 8514/A blitter functionality. Now, it's also very involved, and I'm not going to be able to program this in this video. This document is really serious business. It's over 400 pages, and obviously it would take a very long time to go through all the details here. Fortunately for us, there is another way to do it. The way IBM originally set this thing up is to have a driver called HDI-load.exe, which is a terminate and stay resident program, which sets up an interrupt that we can call that allows us to use all of the functions of the card. The cool thing is I've been able to find a copy of the 8514A Demo Diskette with the HDI-load.exe file on it. Not only that, but there's also an HDI demo program here which should actually show off some of the features of the 8514. So I'm going to give it a try and see if it'll work on this card. But before we do that, let's look at the other card. It's a Hercules card based on the IIT AGX014 chip. And as far as I know, this is the only other chip that's 100% register compatible with the 8514/A. There are other cards like S3 cards and even the Senglabs ET4000 that are reported to be compatible, but only with an extra driver. These are actually compatible at the register level, apparently. Now, according to the board, the BIOS says Graphite card, BIOS version 1.1. The other difference is that they're using a BT RAM DAC instead of an AT&T one, but this is nothing special. A lot of the ATI cards did that as well. The DRAM on this is still 256K by 4-bit chips, and with 8 of them that's 1 megabyte, but no way to upgrade this card to 2 megabytes. And also this is 80 nanosecond RAM instead of 60. But maybe we'd expect that in a slightly earlier card. This is 1992. The interesting thing about this card and what makes it special is it's an ISA card, and that means it'll run in a 286. Who would have thought that you'd get accelerated graphics in a machine that early? It's a little bit hard to find information on the AGX14 compared to the Mark 32 chip. We know it was 16 bits for an ISA slot, and there was a 32-bit version for a Visa local bus called AGX15, but otherwise they were functionally identical. And you can see that there are some high resolution modes with high color depth that were supported depending on how much video RAM you had. And there are also Windows accelerator functions including color dithering, object shading, surface mapping, image stretching and scaling, complex polygon pattern fills, and polygon clipping and window mask. Now these were much more advanced features than the 8514/A provided, but that's because the AGX14 is actually a clone of IBM's XGA standard, which was the successor to the 8514/A. And this was a very powerful standard. It allowed for 4 operand pixel operations. So instead of the ordinary source to destination via some operation that the 8514 would offer, there was a source image plus a mask that you could apply, shading, and then copy into destination, all in one pixel operation. So this was the advantage of XGA, dead standard in the end, but it did influence a number of video cards that were brought to market. Well, I've set a 486 up on the edge of my bench here with the ATI Mark 32 card, so let's try it out and see whether that demo works. And well, yeah, it kind of does. There's a little bit of a glitch at the top of the screen, but it says that this is actually using the adapter interface. And I guess that those polygons that are being coloured there are actually using the blitting function of the card. So this does actually look like it works. Well, let's try the IIT card and see if that works. Now, if I run HDI demo directly, it won't work because it needs the HDI load.exe to be run first to set up that interrupt that we're going to be using. And so now I should be able to run the demo. So let's see if it works on this card. And it doesn't. Well, I have no idea why that doesn't work. IIT actually licensed XGA from IBM, and there are lots of authoritative sources on the web say that this card definitely supports XGA, and of course the 8514/A is a subset of that. So why this is not working, I don't know, and I tried all the jumpers just in case, but yeah, this just doesn't go. Very strange. Well, what I think I want to do now is try out all my other PCI and ISA video cards and see if I can find any others that support this 8514/A interface, because I think the information that's on the web about this is just wrong. A lot of people are confusing hardware support with software support for the interface. Well, I've been through cards with all of the chipsets you see on the screen, and not a single one runs this demo. And that includes the S3 cards, the Sanglabs cards, and even a Mark 64. And all of these are ones which people say at various points online actually work, but I think that they only work with special software drivers that just emulate the 8514/A. So maybe I've missed some. Try it out for yourself. There's a link in the description to the HDI load.exe program and HDI demo.exe. And if you can get something to work, let us know in the comments below. About the only game that we could run is Mahjong 8514 by Belewski, but I haven't got this going. It requires a couple of megs of EMS memory, a mouse driver, and of course the HDI load program. But as you can see, I just get a divide error when I run the game. I'm not the only person that had problems running this. It was only in beta release after all, and unfortunately we can't ask the author. I found a YouTube video about the game where someone posted in the comments that unfortunately Ron passed away last year. And the game didn't really use many of the 8514 features anyway, just line drawing I believe. And I think a lot of people have got it running by using an emulator of the 8514 functionality, which will even run with things like the Sanglabs ET4000, which we know it doesn't have register compatibility with the 8514. So I think we have to move on and try something else, but I will leave a link in the description to the video about that game. There are lots of other spurious reports of games working with the 8514, for example Microsoft Flight Simulator 4 and SimCity 2000. But if FS4 worked with the 8514, for example, they'd probably say something about that on the box, and as far as I can see, they don't. But something intriguing has caught my eye. This is Borland's Turbo C, an implementation of the C programming language, and their graphics drivers are called VGA. You can see that it supports CGA, EGA and VGA, Hercules, there's PC3270 and maybe some others here, but the one that caught my eye, of course, is IBM 8514.VGI. Now, I'm betting that this is the graphics standard, so I think I can write a short C program and see whether this works. Well, I think I've been successful here. 6 is the code for the IBM 8514 graphics driver, and the modes are either high or low resolution, so I chose the high res one. And it initializes the graphics mode, sets a solid fill red, and draws a bar on the screen and waits for a key to be pressed. So pretty simple program, but let's give it a go and see what happens. So if I run this, and the good news is that this will only run if I run the HDI load program, which means it really is using the 8514. It takes a little while to start up, but there we have our bar. Now my monitor doesn't support the high res very well. The low res works fine, so I'll switch to using that. And let's see what we can do. Well, in order to see how fast things are, I've written a program that draws 10,000 random rectangles on the screen in random colors. So let's run this and see how many seconds it takes. So it takes a while to start up, and wow, that is amazingly quick. Look at that. That is just superb. I can't believe how quick that is. So that was what? 10 seconds to draw 10,000 of them. So it's drawing 1,000 rectangles a second. That is impressive. Well, this is a 486, so perhaps it can be expected to go fast. Maybe just any old PCI VGA card will do. So I've put in a Senglabs ET4000W32, and I've rewritten the program to just use ordinary VGA instead of 8514, and it does exactly the same thing. It's going to run in 640x480 resolution, the same as the other one. So let's try this and see if it's any slower. And well, I would say that's about the same speed actually, so I'm not sure that we're seeing a whole load of speed up with that blitter. Perhaps we'll only see that when we run it on a 286 when the Mark 8 card comes, which should still run this, and perhaps there we'll see a big speed up. Well, I think that's a good place to stop our 8514 experiments. We need to wait for the Mark 8 card to turn up. That's an ISA card and sort of run at a 286. So there we won't be trying to compete with the 486, which is really fast anyway. We'll still put an ET4000AX in, that's an ISA ET4000 card, and we'll do a comparison there, and maybe things will be a little bit different. It'd be great if it was, because can you imagine writing a game or a demo effect or something like that with a blitter on a 286 machine and having it just blaze through, you know, drawing polygons and all sorts of things like that. So stay tuned for that in a later video. The card is on its way and I'm pretty confident it's going to work, and that'll be in a later video. But that's not it for today. I actually have a little bit of a surprise, and this comes courtesy of an eagle-eyed viewer who spotted this Paradise Systems card on an auction website and pointed it out to me. Well, I decided to acquire it, and it's a really unique piece of computing history. You don't often get to see things in original boxes from this far back. It's just a CGA class card, but it has some interesting features, which is why the viewer pointed it out, and I'll show you that in a moment. The only other thing to see on the front here is it has a 1-year warranty, probably expired by now, and it says high-res graphics with standard monitors. Intriguing. Admittedly, the most interesting thing is going to be the box itself and the chips on the card, rather than seeing the thing run in practice. And the reason for that is because it's a rare glimpse into how this card was actually marketed back in the day. Very often you get a card and you have no idea what it was for, or even what hidden features it might have. And here it is all laid out for us. So there were two modes, monochrome and color, and there's actually a switch on the board, a physical switch to switch between the two, which I'll show you. In the monochrome mode, you've got 720 by 350, which is a high resolution monochrome mode. It's Hercules compatible, and there's a whole bunch of software that supports it, which is interesting. And then there's just the standard 80-column text mode, like the IBM monochrome display adapter. In the color mode, we have high resolution, so 640 by 200 at 4 colors and 320 by 200 at 16 colors. Well, I would say those are not really high resolution, they're simply high color modes. And if you recognize these, that's because recently on the channel we talked about the Plantronics COLORPLUS. So yeah, this card actually supports the Plantronics modes. And that's really interesting because getting an original Plantronics card would be really hard, but here I have one that supports those modes, and it's actually not a very large card either, as you'll see. So that supports a whole bunch of software, and then there are just the standard CGA modes, which we already know all about. The rest of it is pretty mundane, so the only interesting thing here perhaps is flicker-free scrolling. It also makes a claim of 100% IBM hardware and software compatibility. Well, we'll certainly see about that. Well, let's unbox it, and unfortunately there's not going to be original packaging in here or a manual or anything, but the thing was very, very cheap. You know, if I actually had to buy a Plantronics COLORPLUS card, well, I couldn't afford to. So it's really nice to have a very, very cheap card that actually supports those modes that I can put in any PC I want. Well, I'll quickly try this out to make sure it works, but here's a brief glimpse, and there's the switch that I was talking about that goes between color and mono modes. Well, I made a bit of a mistake by not turning the camera on to prevent anything interesting happening when I plugged the card in, and unfortunately something interesting happened off camera. There was a big spark when I turned the machine on, a massive amount of smoke which smelled absolutely terrible, and this is the aftermath. You can see there's a burned tantalum capacitor on here. It's totally smoked. Even worse than that, it's left a massive stain inside my PC. It's just amazing. I've never seen such a load of gunk come out of a capacitor before and leave such a big stain. Hopefully that just wipes off. Well, you can see that I've removed the capacitor here. I just snipped it off. It's not going to be used for normal operation. It's just some kind of smoothing cup, probably across the supply rails. And that's the remains of the capacitor there. You can see it really made a total mess of that thing. So I might just replace this with another tantalum now. I'm not sure what the value is, but it's probably not hypercritical either. As you can see, it's left a pretty ugly mark inside the case. I mean, I've tried all sorts of things to get that off. Acetone, IPA, various other cleaning chemicals. That's about the best I can do. If you have any ideas or suggestions of how I could get rid of that stain, let me know in the comments below. Before I do anything to the card though, let me just turn the machine on and we'll make sure the card is actually working without that capacitor. It's not going to be needed, it's just a smoothing cap across the rails most likely. So I am anticipating that we'll get an image here, and yeah, it seems to be working just fine. Well, there's the new capacitor, and it's a good visual match for the other capacitor that's on here, so it looks good, which I know some of you care about. And I decided to save you yet another soldering montage on the channel. I've just gone ahead and put that in. Before we move on though, let's take a look at what's actually on this board. I didn't have much luck tracking down information about some of these chips, and that's because many of them are Paradise, and some of these are going to be custom ASICs, so there just won't be very much information available. But here's a close-up in case some of you have more luck than I did tracking down some specific information. If I look at the date codes, there's quite a lot of 87s, and I think I saw an 88, but of course VGA was already out by then, so this is a very late CGA card indeed. The only chips that I could really identify were the 6845. This is a standard CRT controller which you'd expect to find on a CGA card. It controls generation of the text and graphics modes. You wouldn't expect to see a 16 MHz clock crystal on a CGA card, but perhaps one of the ASICs required a signal, or maybe there's even a small microprocessor in there, who knows. This is a parallel port controller chip, PPC1, which is used on a few different systems. Of course, there's a parallel port here. And I did manage to find a reference to this L1A2099. I don't know what it is, but there's an advertisement for what looks like another graphics card that's switchable between colour and mono, which is already selling for £10 in 1990, so not very much indeed. And there isn't very much more to say here. There's a BIOS chip, of course. This is the memory here. That's slightly interesting in that these seem to be 64K by 4 bits each, which means that you have a total of 64K bytes. And that's more than you'd expect. In Plantronics, you only need 32K bytes, so I don't know why there's twice as much, but perhaps there's just an extra page for page flipping. That would be interesting. Now, one of the selling points of this card was that it uses switches instead of jumpers, but there's only 2 of them on here other than the color mono switch, and they're just for switching the parallel port I/O address, I think. Probably just a light pan and composite connector here, or something like that. Nothing very special there. There's a bunch of 74LS logic chips, all very standard. So I think this is basically a late CGA card. The thing that makes it interesting for me is really just that Plantronics COLORPLUS support. Without further ado, let's test the 100% compatible rating that Paradise claimed for the card. This is the most unfair test that I can do. It relies on an improper mode that was only discovered about a decade ago by a demo scener by the name of Reichert. I wrote this demo to work with the IBM CGA card, but it doesn't look quite right here. The background isn't the right color, there's the extra cyan bar next to the chessboard, and the chessboard itself doesn't have straight lines due to slight differences in the font. So I'm not going to give it a 100% compatible rating, but that doesn't mean that it wouldn't have got one back in the day. Let's dig a little deeper. Here's another completely unfair test using a different improper mode this time. On a genuine IBM CGA card, this would have snow and it would be garbled due to addresses being latched at the wrong time in this mode. But here it works perfectly, it looks great. It only fills half the screen, but I have to wonder, with the extra VRAM on this card, perhaps we could get a version of this that runs in full screen sometime in the future. Of course, the real acid test should be Jim Leonard's CGA compatibility tester, which I'm running here. I went through all the tests, including this complex row reprogramming effect, and everything seems fine. Of course, this card has no snow, but that's hardly a feature of the IBM CGA card in the first place. And also, the fonts are a little bit different, but you might expect that given that IBM's fonts were copyright. But everything else is the same, and in fact this card is just slightly faster than the IBM CGA card. Nothing special, just a little bit. So yeah, Paradise has done a pretty good job here. Thanks to the viewer who pointed out that Paradise video card listing, and thanks also to all the viewers on the previous video who pointed out my error. The SCART standard is in fact French, not British, as I had guessed in the video. You know, now that you mention it, I can see this being designed by the French. Obviously, it had to have RGB support and composite support in there somewhere, and a whole load of other obscure video standards, most of which I've never heard of, all in one complex adapter with a multi-prong approach. Yeah, I guess it was designed by a panel of French bureaucrats. Anyway, all silly jokes aside, speaking of bureaucracy, it's time that I gave a channel update, and I've been hinting at this for a while. I want to get away from Germany, where there are a lot of rules which are very hard for a foreigner to understand, many of which affect YouTube. So I had planned to go back to Australia, where I am from, but in the meantime I seem to have been offered a job in the UK. And if that goes ahead, that could have some consequences for the channel. First of all, I do have to go back to Australia either way for a holiday, and I think that's coming up soon. Obviously the videos are not made at the same time that they go up on YouTube, but I know it's coming up. And that is so that I can visit my family. I haven't been there for 3 years because of the event. But if you want to know why that may make a break in transmission on the channel, well, ask the Australian government how internet's going in rural Australia. And I don't know when I'll be back either. Ask the Australian government about the passport crisis. Unfortunately, I need to update mine when I get back there. Anyway, assuming that I eventually get back to Germany and then on to the UK, what will that mean for the channel? Well, apparently any British person can start a YouTube channel and monetize it. But as a foreigner with a visa, that may not be possible. There are some shortage occupations in the UK. Apparently computer programmer is one of them, and so maybe I can figure out a way to do some vintage computer programming as a side gig. But as for the channel, it will have to remain a hobby channel. I would just upload when I find time, and it would just be about my personal hobby. But that could create some opportunities. First of all, I don't have to care about what the algorithm thinks. I made a video on 3D effects recently that completely bombed on YouTube. YouTube probably doesn't even know what 3D effects is. And obviously to be successful on YouTube, you have to appeal to an audience that's much broader than your core audience. That's you guys. But if you don't care about the algorithm, well, you can focus on the things that you and I enjoy. So if you have any suggestions of things you'd like to see me make videos about, put them in the comments below and I'll give it some thought. I might make videos on a slightly more relaxed schedule and maybe spend some more time doing programming so that we can really see what these cards can do. And yeah, just make them a little bit more epic. And I think that could be a lot of fun. So there's definitely some opportunities there, and no business means no ads. That's got to be great for you guys. Anyway, as I say, that's it for me this week. Obviously there'll be more about this in the future, and I think there could be another video before I actually go on holidays. If not, I'll see you in a later video. Bye.